Hello and welcome to another review from Optics Trade Debates. Today we'll discuss the term fogproof. The first question would be, with what are these optical devices filled with?
Well, I would still go one step backward. Fogproof.
Okay.
Why is this so important? And what does fogging in optics actually means? It's basically, this happens, the fogging in optics happens when the optics experience a rapid change of temperature. That means you have an optics inside, indoors, at let's say 25 degrees Celsius, and you go outside at -20. That means 40 degrees Celsius of a temperature change. And what happens if inside of the optics is air with any kind of moisture, then internal condensation will happen. Because of the temperature change, the water will start to form droplets, small fog inside of the optics. So if the optics is not fogproof, that means that you will not be able to use it in winter or anywhere where there are, I would say, substantial temperature differences. So this is what fogproof means. It means actually that there is no moisture inside of the optical device. And this is usually achieved so that air is replaced with either argon or nitrogen. But it's not only argon or nitrogen, they have to be dry. So they have to be completely without any moisture, without any water. Then there is no water inside that would be able to condensate when you expose your optics to a different temperature. When you expose your optics to a temperature change.
Yes,
this is
of course.
actually the...
Okay, but which products, which optical products are filled with either these two gases, and which are not? First, which are?
I would say high quality. High quality products are all filled. I would say majority of rifle scopes, red dot sights, these which are full tube or small tube, not the reflex. The binoculars, almost all binoculars nowadays are almost fogproof, and monoculars. These are all filled in most cases with nitrogen, in some cases also with argon, and these are all fogproof. That means also that they're waterproof, because if an optical device is not waterproof, it also cannot be fogproof, because if the water can go in, then air can also go in, and if the air comes in, then you have no fogproofness anymore, because every air, and air is air always contains some water and some moisture. So if the air comes inside, the moisture comes inside, and then there is no fogproofness anymore.
Okay, so which devices are not filled with either of those two gases?
All those devices which are not completely waterproof. One most common optical device which is of this type, where even the most high quality products of this type are not waterproof and fogproof, are extendable spotting scopes. So when you do this, the air goes inside, and when you do this, the air goes outside. You can even hear the sound.
Yes.
It's like a pump. So even the highest quality Swarovski or Meopta of this type, or Optolit, it will have the same problem. So these devices are not fogproof, because there is always air inside, and they're also not waterproof. So if you expose this spotting scope of this type from any producer, I think at least there is no producer who will be able to produce this type of optics completely waterproof and fogproof. If you expose it to a temperature change, then it will not be fogproof, because it will condensate, the water will condensate inside. This is one example. And the another example are usually the spotting scopes, because I would say 99% of all spotting scopes come with you can remove the eyepiece. So in this part and in this part, the air goes inside, the moisture goes inside, and it's not fogproof. The eyepiece itself can be waterproof and fogproof, and the body itself can be waterproof and fogproof. But this internal part where the eyepiece comes to the body, this internal part is not waterproof, and that means it's also not fog-proof.
Yes, this still means the gas can, the fog can still get through to the lens.
So if you have this at 25 degrees or 30 degrees indoors, and then you take it out at -10 or -15 degrees Celsius, fogging can occur in this part. It's normal because there is air inside, and because it's air, it's also some moisture.
Okay, for which optical products is it better to go with argon or nitrogen, or which one is better for certain optical product?
None. Well, they say argon has a little bit bigger molecules, and that means that if you have a leak, it will, I'm talking about really nano-sized leaks, that it will stay inside for a longer, prolonged period of time compared to nitrogen, because nitrogen is a little bit smaller and all the molecules can go out. But in reality, this is a lot of marketing talk. In reality, both of them work the same. And if you have a leak, the leak will be as big that both the nitrogen and argon will go out and the air will come in no matter what. If there is no leak, then also the argon and the nitrogen will both work the same, because the main idea is not to have argon or nitrogen. They don't affect any optical properties. They don't affect anything. The idea is to have completely dry gases. So dry argon or dry nitrogen. They could use even any other gas. It will still work all the time if there is no water present. So basically, the choice between argon and nitrogen, it's not really a choice. It's more of marketing, because nitrogen is, you can find it anywhere, and argon only is used by some manufacturers, not many.
Yeah, it's funny that you mention it. I know some manufacturers who produce all of their optical products only with argon or with nitrogen.
So it's a good marketing move. You say we have argon inside, but it doesn't affect anything. The main point is that you don't have any water inside or any moisture. So I think we covered mostly, or are there any other questions?
I think we covered most of the questions, but nonetheless, if you have any additional questions which we forgot to elaborate on, please subscribe to our channel or leave a comment below, and we'll see you next time.
Thank you.